class 10 CBSE. The same lesson of the chemistry, that is the chemical equation, chemical reaction and the equation. Today we are going to study about the chemical equation. In the first part of the video, the first class, you know very well what is the chemical reaction. It is a process in which some substance turn or convert or form any other substance by the combination or by the because of the some reaction. So it is called the reaction between the chemical. So it is called the chemical reaction. Today we are going to study about the chemical equation. If some reaction is performed, we have to express that reaction. One way, you have to write in the sentence. For example, magnesium combines with oxygen to form magnesium oxide. This is the one way to write this. It takes a huge place, a long line is there to be write. First, that is called the statement way. Equation or chemical reaction in the form of a statement. Okay. Another method is also there, that is called the word equation. First is the statement. What is the statement? Magnesium combines with oxygen to form magnesium oxide. This is the statement of the chemical process. If we want to represent it in a way, then one way is there, that is called this statement. One is called the word equation. What is word equation? We are able to write like this. Magnesium combines with oxygen to form magnesium oxide. But there is some other way also to represent the chemical process. That other way is quite easy, time consuming and space consuming also. And that is called the chemical equation. Chemical equation is actually the representation of chemical change or chemical process in the form of symbol and formula. Whatever the substance which is involved, all the substance is represented with the help of symbol and formula. So what is the chemical equation? Chemical equation is representation of chemical process with the help of symbol or symbols and formulae. Now what is the chemical equation? This is the word equation we must write here. Now I am going to write the chemical equation. Magnesium, that is symbol of magnesium. Oxygen, we know that oxygen is always exists in molecular state. So we have to write here to combine to form magnesium oxide. This is called chemical equation. This is actually chemical equation. What is chemical equation? It is actually the representation of the chemical process with the help of symbol and formula. We are taking it as example and complete it. This is the example for the chemical equation. Now I am going to write here 2. Here also 2. That is called the balancing. And what is the balancing? We have to study it today only in this class. But before the balancing, we have to know what are the rules for writing a chemical equation and how can we make our equation more informative. So first, what are the rules for writing chemical equation? Rules for chemical equation. Rules for writing chemical equation. Now what is the first rule? According to the first rule, we have two parts of the reaction. One arrow is placed in between, one is before the arrow and one is after the arrow. Okay, this is one equation that we are taking as example now. 2Mg plus O2 gives 2MgO. This part is called reactant. Okay, and this is called product. What is reactant? The chemicals or substance which participate in reaction, which perform process. And what is the product? The chemical or chemicals or substance which is produced. That is called the product. The one is reactant and one is product. In any chemical equation, two parts are there. So we have reactant, also we have the product. We have to write all the reactants. Write reactants in left hand side. Again with the help of the symbol and formula only. Okay, with the help of symbol and formula. Okay. Now what is the second rule? We have to write all the product in right hand side. Write products in right hand side with the help of symbol and formula. But it often happen that reactant or product is more than one. So if reactant and product is more than one, then what you have to do? Place plus sign in between them. Look at here, two substances are there in reactant. So I write one plus here. This plus percentage we have to add this. So if the reactant or product is more than one, then we have to use the plus sign. One more important thing, we have to place an arrow between the reactant and product. We have to place an arrow. This arrow symbolizes the direction of the reaction also. An arrow is placed between reactant and product. This arrow also represent the direction of reaction proceeded. Direction of reaction proceeded. So this is the rule for writing the chemical equation. So next is, how do we make the chemical equation more informative? How do we make the chemical equation more informative? why the information is needed? It is needed because by observing an equation, we are able to understand the maximum what is happening in the process. How do we make the chemical equation more informative? We are able to write the physical state of reactant and product. Okay, we are able to write the physical state of reactant and product. We are able to write the physical state of reactants and products. How we represent this physical state? Some letters are there. We are using certain letters such as by using certain letters. Okay, that is S, that is small s. The small s is representation for solid. L is for liquid. Small g is for gas. Okay, if we make the solution of the substance in water, then we have to use AQ, that is called aqueous. Okay, if any gas is evolved in the process, we have to use one upward arrow. This upward arrow shows the formation of gas. If some precipitate is formed in the equation, then we have to put one downward arrow. This shows the precipitate, formation of the precipitate. So this is the way by which we are able to make the chemical equation more informative. For example, what happened in photosynthetic reaction? Carbon dioxide or 6 carbon dioxide combines with 6 water to form C6H12O6 plus 6O2. Okay, what about the carbon dioxide? Carbon dioxide which is present here, that carbon dioxide is actually dissolved in water. This carbon dioxide is dissolved in water, so state is AQ, aqueous. What about water? Water is always liquid, so we have to write here N. Okay, what about this glucose? It is aqueous in nature. Okay, the oxygen which is walled here, it is also in the aqueous state. So we must write here AQ. In some other reaction, zinc combines with sulfuric acid to form zinc sulfate. And in this process, hydrogen gas is evolved. Here zinc is solid. This is aqueous, the solution of the sulfuric acid in liquid, so it is aqueous. This is again, it is aqueous. And what about this? This is a gas. So we must put upward arrow, or we have to write this G. Okay. If in any other process, if some precipitate is formed in the first class, you must you know about the reaction that lead nitrate combined with the potassium iodide to form lead iodide and potassium nitrate. In that process, the precipitate is formed, and that precipitate we have to put one downward arrow. Now, what is another thing which makes the chemical equation more informative? That is the balancing of the chemical equation. So, next topic, it is very much important topic, that is called the balancing of chemical equation. Whatever the number that I am written 2, 6, whatever that number are, that is the balancing number. So, next and the important part of this topic is the balancing of chemical equation. So let's move towards that. Balancing is one most important part of the chemistry, and it highly depends upon your practice matter. It is a practice matter. Practically, it is a practice matter. We have to study the various steps, but again and again I am going to repeat, it is a practice method. You have to practice a lot. Okay. Balancing of chemical equation. Balancing of chemical equation. Okay. The first question is, why the balancing of chemical equation is important? The balancing of chemical equation is important because in any chemical process, according to the rule or law of combination, atom neither can be created nor destroyed. The number of atom in the reactant is always equal to the number of atom present in the product. So we have to balance that number of atom by the process called the balancing of chemical reaction. Again I repeat, the balancing of chemical equation is very much important because it is based on the fact that in any chemical combination, atom neither can be created nor destroyed. So the number of atoms present in reactant is always equal to number of atoms present in the product. Now what are the various steps for balancing a chemical equation? Let us take an equation. For example, magnesium combines with oxygen to form magnesium oxide. Now one more thing. If some statement is given there, for example, sodium combines with water to form sodium hydroxide and hydrogen gas. Okay, this is the statement. So you have to convert this statement, or you have to convert the word equation in this equational form with the help of symbol and formula. How can you are going to form the formulas? For that, you must have to revise your 9th class portion, that is of the ion. Some ions are given there, positive ion and negative ion. You have magnesium, you have oxygen. You know that in magnesium 2 positive charges are there, and oxygen 2 negative charges are there. As you know that, you have to set this 2 here, you have to set this 2 here. You have to simplify it, 1 and 1. Then we have to cross multiply it. And what we get here? Mg and O, and it is called MgO. So this is the way for making the formula, easiest way, and you have to revise this portion from the 9th class textbook. Okay, so we have this equation. We have to balance this equation. So what are the various steps of balancing? The first step of balancing is draw boxes around each formula and and must ensure that you are unable to change anything inside the box. I am going to draw the box like this. Okay, you have to draw boxes outside the present formula and the symbol, and you have to ensure that you are unable to change anything inside the boxes. You are unable to change anything. Whatever the change is going on, you have to mention outside the boxes. Okay, first rule is that. What is the second rule? Second rule, you have to list the number of atoms of different elements present in reactant and present in the product. So you have to make a list. I am going to make a list. Okay, that is the number of atom. Or first is the element or the symbol of element or the symbol of element. So this is element or elements. Then number of atoms in reactant. As we know that there are two parts of the reaction. One is the reactant. This is called reactant and this is called product. Then number of atoms in products or product. Okay, we have to make a list. Now first list it out, how many atoms, how many elements are present here. In the given equation, 2 elements are there. One is magnesium and one is oxygen. Okay, this is a small list. Now count the number of atoms present in reactant and number of atoms present in the product. In reactant only 1 Mg is there, so we write here 1. What about the oxygen? In reactant 2 oxygens are present, so we have to write 2 here. Okay, simple counting of the atom. What happened in the product? See, here 1 Mg is present only and 1 O is present only. You saw the change in the number of atom. In the number of atom present in the reactant is 2 plus 1 is 3. Here 1 plus 1 is 2. It means one atom is reduces in the product, and we know that according to the law of chemical combination, in any chemical reaction atom neither can be created nor destroyed. So what we have to do? We have to balance that number by giving some number by ourselves. Now what we have to do? Whatever the number we are providing, that always to take place as the multiple stage. Okay, that is multiplication of 2. Now here 2, here 2, here 1, here 1. Total 3, total 3. But that 2 that we are writing here, where that 2 is placed? That 2 is placed in the product. And only one product is here, that is MgO. And according to the rule, we are unable to change anything in the box. What we have to do? We have to place that 2 outside the box. I am going to write here it again. Mg plus O2, and this is formed MgO. So where we have to place this 2? We have to place this 2 outside the box. And what is meaning of this 2? This 2 is common for Mg as well as for the O. This 2 multiplied with 1 and it's become 2. But what happened when this 1 Mg is multiplied with 2? It means when the 2 is common for all this, it is also multiplied with 2. Again the ratio is disturbed. Here the 3 and here the 2 plus 2, 4 is there. Then what we have to do? We have to multiply one more here, 2, and we get the 2. And where this 2 is placed? This 2 is placed here. Now the equation is balanced. Okay, what are the various steps of balancing? First, you have to make the boxes around the symbol or the formula, whatever the given is there in reactant as well as in the product. Then you have to make the list. They have to check the number of atom in both the place, and if by using the hit and trail method, that is simply you have to practice it well. And by using the hit and trail method, you have to balance all this. Okay, we are going to take few more equation. The photosynthetic equation, that is carbon dioxide combines with water. As we know that if reactant is more than 1, we have to put 1 plus sign in between. In the presence of chlorophyll and sunlight, it gets converted into C6H12O6, that is glucose, and oxygen. First, what have to do? According to the rule, you have to place one box around this formulas. Okay, this is the first step. What is the second step? You have to make a list. I am going to make a list. First is the elements. Second, number of atoms in reactant. Second, number of atoms in product. Now you will know that what is reactant and what is product. The substance which is present before the arrow is reactant, and after the arrow, that is the product. Now whatever the elements present here, first is the carbon, second is the oxygen, and third is the hydrogen. Only 3 are here. Okay, 3 elements are here: carbon, oxygen, and hydrogen. Now count the number of the C, O, and H in reactant. C, only 1 is there. O, here 2, and here 1. I am going to write it separately. 2 and 1. Okay. And H is 2 here. Okay. Now go and count the number of this atom in the product side. C is 6. H, only one place is there, and it is 12. What about the O? O is placed in 2 places, and in one place it is 6, and in another place it is 2 in number. Okay. Now we are going to balance it. Now first, the carbon is 1, here the carbon is 6. Now how can we convert this 1 into 6? That is simple, multiply with 6. Now 6 is equal to 6. And you know that where the 6 is placed here in the equation. I am going to write it again. CO2 plus H2O gives C6H12O6 plus O2. I have placed this 6 here. Okay, because only one carbon is there, and that carbon is only this, and we know that this 6 is common for carbon as well as for the oxygen. So this 6 is multiplied with this oxygen also. Which oxygen? The first oxygen. What happened here? It gets 12. The carbon number is equal in both the sides, but oxygen number is not equal. First we move towards this hydrogen. What happened for the hydrogen? Here H2, here H is 12. Okay, what we have to do here? We have to multiply this 2 with 6. Now it is 12, it is already balanced. Now it is 12 and 12, it is balanced. Where we have to place this 6? This 6 is placed outside this H2O. Now what happened? This 6 into 2, 6 2s are 12. Here 12, here 12 equal. But this 6 is for O also. So we have to multiply this 6 here. And this is the 6. So what happened here? 12 plus 6, it is 18. But here 6 plus 2, only 8. So we have to increase the number of 6 here. How can we increase? We are going to multiply this 6 with 2. 6 2s are 12. Now 12 plus 6, it is again 18. And we have to place this 6 here. This equation is now balanced. Once again, I told you I am giving few questions in the homework. A practicing section. For practicing section, you must have to practice it. It is the easy process, but you have to practice it well. Without practice, you are unable to perform it.